Welcome to our 5th Let's Talk Sustainability event. Our first one was over 2 years ago and we concentrated on decarbonisation. Today what we'd like to do is update you on what we're doing, tell you about some of our projects, tell us what our thoughts and our ideas, but more importantly we want to explore how we can collaborate across the sector because we can't solve this on our own. So, Heidelberg Materials. Previously we were Hanson UK and we rebranded last year to Heidelberg Materials. We did this because we realised that this is a global problem, a global challenge, and we need, as Heidelberg, to collaborate globally to solve it. We're the leading supplier across the world of low carbon, heavy building materials to the construction industry. You can see what products we produce, and we're represented in over 50 countries for 150 years. And we've got 51,000 employees. One of our key commitments is to decarbonise the built environment and to grow that circular economy in building materials. When you look at building materials, they represent 40% of the carbon in construction. I know there's a whole range of different projects, but this is for a typical apartment block. 40% of the carbon comes from building materials. And then if you look at that further, out of that 40%, 20% or half of it comes from concrete. In fact, as you can see, when you look at construction materials, it's about concrete and it's about steel. So as we look more about concrete, 90% of that carbon comes from cement. Cement, we know, represents 7% of the whole world's emissions of CO2. So that's what we're trying to reduce. So the obvious first thing we should do is we should use less cement in concrete. It seems a really obvious thing to do, to say, but actually it's very difficult to change the way that we work. Concrete is a very long-term product. In fact, actually concrete is the most used product after water in the world, and it's infinitely recyclable. So by that very definition, if you can keep on recycling it, it's going to last a long time. So people are a bit cautious about changing how we design concrete, but we know we can make concrete with an awful lot less cement in it. And we need to change and we need to explore how we could do that quickly. When we look at cement, which is, as I've said, the main producer of CO2, we know that cement has CO2 from its process emissions, so making the CO2, the fuels that we use to make the cement, the fuels that we use. And then the second is the chemical reaction that emits 2/3 of those CO2 emissions as we produce the cement. So what do we have to do? Quite logically, we need to reduce the amount of emissions from our energy and from our fuel. That means we're using alternative fuels such as hydrogen or using waste fuels. And we're using low carbon electricity, using less electricity, looking at solar, looking at electric vehicles. We've got to do that. We can do it now. And as Heidelberg, we're driving down those emissions all the time. But we can do more and we can do it quicker. But despite all of that, we're still left with the CO2 that's emitted from that chemical reaction. So what can we do? We can capture that CO2 and we can store it. And we can store it in depleted gas wells off the coast of the UK. This is a picture of Padeswood. It's a cement plant in North Wales, and we're in the process of completing our engineering design to install a massive plant there to capture the CO2 that goes up that stack, to clean it up, to pressurise it and to pump it out into those gas wells as part of a consortium. And we'll tell you more about that later. So that's a lot about CO2 and decarbonisation, but we also need to remember it's about recycling as well. It's about reducing that virgin material intensity in the products that we use in construction. And that's why the acquisitions that we made of A1 a couple of years ago, and hopefully tomorrow we'll finally complete the acquisition of Mick George, which will transform our ability to use these secondary materials in our building products. So to make it really work, we need to improve that transparency and verifiable information. the client, the customers, everybody, all the stakeholders need clear carbon data. And it's up to us to provide that data in the format that people need. Consistent data across everybody in the industry. As Heidelberg, we've got a clear commitment, net zero by 2050. But 2050 is a long way away. So we've got some interim targets and interim objectives, what we want to do by 2030. But we can't deliver those alone. We need to collaborate with everybody in the supply chain, all of our customers, the clients, the specifiers, with government, etc., to make sure that we can achieve those targets and we can deliver it. So I'll see you later on this afternoon where we can talk more about this. But in the meantime, can I hand you over to Marian Garfield, our Sustainability Director, who will take you through the agenda for this afternoon.
Great. Thanks, Simon. And good afternoon. I'm Marian Garfield, the Sustainability Director for Heidelberg Materials. I'll be hosting today's event, the fifth in our Let's Talk Sustainability series. We're due to run till about 4:30, and we'll be having a break in the middle. During the first half, we will be discussing our plans and how we are aiming to achieve net zero and how we are tackling this decarbonisation challenge by reusing concrete paste in cement production, reducing carbon in our asphalt business, and the deployment of carbon capture activities around the world. After the break, we will be looking at how to bring these innovations to life in our products, and we will be joined by the Head of Sustainability for Careys, with whom we will be having a discussion around carbon reduction from a customer's perspective. We would like to make this session as interactive as possible. So on your screens now, you will see a QR code for the Slido system. So please can you scan using your phone and send through any questions you have. It should just have appeared on your screen. We will be having a questions and answer session at the end where we will be answering as many of your questions as possible. And obviously any that we can't answer today, we'll be putting it together as a feedback after the session today. Just to make sure this is working, it will be really interesting to see how many of you have attended these Let's Talk Sustainability events in the past. So on the Slido now, you will see a short poll. Please fill that in and we'll update you with the results later. So, I'm convinced that sustainability is a common goal in which everyone should participate and contribute. And it's so great to see so many customers and colleagues and academics joining us today. As Simon just said, cement and concrete will play an important role in the infrastructure of the future. Concrete is durable, fully recyclable and produced locally. Given its resilience to extreme weather, events such as drought and severe storm, it plays an important role in the mitigation and the impacts of climate change. The production of cement, the binder in concrete, is CO2 intense, and therefore the construction industry is one of the biggest producers of carbon emissions in the UK. However, we also have an opportunity to make a significant contribution to carbon neutrality. At Heidelberg Materials, we have a clear sustainability strategy and accept our share of responsibility to limit the rise in worldwide temperatures to 1.5 degrees. Our sustainability commitments 2030 cover topics under 4 headings: net zero, circular resilience, safe and inclusive, and nature positive. We have a clear ambition to reduce our CO2 emissions to net zero by 2050 at the latest, but we can't do this alone. So today, we're going to be sharing what our plan to a net zero future looks like. And the entire supply chain will need to work collaboratively together to ensure we all meet our sustainability ambitions in the future. Our efforts are not limited to business processes and figures, but are reflected in all of our actions. And we are determined to build a sustainable future. We accept there are no single actions which can be taken to achieve net zero, and therefore are developing our net zero plans based on a clear carbon mitigation hierarchy. The first and the most effective step for companies to reduce their carbon emissions is to prevent the emissions from the onset. By prioritising a manufacturing strategy that favours products using less materials than when used by the end user, companies can make significant strides towards their carbon emissions and reducing their targets. Ultra high performance concrete and 3D concrete printing are particularly effective solutions to this challenge. Ultra high performing concretes are characterised by very compressive strengths. That means they can be used to build concrete structures that are remarkable for their economic use of material, as well as their reduced weight and slim construction. 3D printing in construction is an upcoming new way of building that, through robotic automation, allows for the reduction of material usage, the reduction of waste, the increased process efficiency and safety, while ensuring enhanced design freedom. Traditional waste associated to traditional concrete construction can be eliminated, for example, no framework, no process waste, and the automation ensures accurate application. The second step a company can take to reduce their carbon emissions is to develop products with reduced CO2 emissions. We have been working for several years on the development of alternative binders with the aim of reducing or even completely replacing conventional clinker. Regen, commonly known as GGBS or ground granulated blast furnace slag, is a great example of this and is readily available now as a reliable cement substitute. GGBS can replace a substantial part of the Portland cement content, generally about 50%, but sometimes up to 95% in special applications. It can be used anywhere concrete is needed, from sustainable housing developments and soil stabilisation to wind farms, road, and is typically used in major construction projects such as bridges and sea defences. By using 1 tonne of regen in concrete, this reduces the embedded CO2 emissions by about 900 kilograms compared to using 1 tonne of Portland cement. Another example of developing products with reduced CO2 emissions is calcined clay. If this is substituted for the energy-intense clinker, by using calcined clay as a clinker substitute, in principle, could provide a CO2 reduction of up to 40%. This will allow us to significantly expand the range of low carbon products we have available. Another strategy to reduce carbon emissions in products is to look at the entire life cycle of our current products and embed the principles of circular economy into our business strategy. Our circular economy strategy is clear. We want to save raw materials and contribute to significant CO2 savings, from improving recycling technologies that enable the reuse of concrete in new buildings to formulating cements with reduced clinker content. As concrete can be fully recycled, our industry is in a good position to do this. More can be done to achieve through recycling. On one hand, this saves primarily raw materials such as sand and gravel, which are used in aggregates in the production of concrete. And on the other hand, the fine materials obtained when breaking up and sorting waste concrete can be separated off, so-called cement paste or recycled concrete paste, RCP, carbonated and then returned to cement production as an alternative cementitious raw or fill material. We will be hearing more about an exciting project for Nina in a few minutes. Asphalt is 100% recyclable. Using a recycled asphalt planings or RAP in the asphalt production process avoids using virgin aggregates, protecting natural resources for future generations. It also reduces the use of bitumen, supporting the circular economy and reducing carbon emissions. Our concrete-placed asphalt contains additives derived from waste plastics. It is produced at a low temperature using our energy-reduced asphalt warm mix process, which is mixed at 40 degrees at a lower temperature. We use chemically modified waste plastics and is comparable to bitumen without compromising performance and prevents the plastic from going to landfill. Recycled plastic can also be recycled back into the new asphalt at its end of life. The next stage in the carbon mitigation hierarchy is the substitution of emissions. Using alternative fuels like biomass or waste material has an immediate beneficial impact to our carbon footprint. We have signed an agreement with our electricity providers to only use carbon neutral electricity, enabling us to reduce our CO2 emissions from its source by 97%. Our cement works at Ketton has a third of its annual power consumption supplied by a neighbouring solar farm. Our cement works at Ribblesdale has successfully proven the cement kiln can be operated on a zero a net zero fuel mix. During the trial, we used a mixture of hydrogen, NBN and glyphosate instead of burning fossil fuels such as coal. We have also trialled the use of hydrogen, which is burnt alongside SRF as a fuel enhancer. To reduce our reliance on diesel in the machines on our quarries, we are trialling the hydrated vegetable oil, or HVO, fuel at our Chipping Sudbury quarry. Using HVO will help us to eliminate up to 90% of the net CO2 and significantly reduces NOx and particulate matter and carbon monoxide emissions. And our asphalt business, we are exploring alternative fuels to diesel, such as gas to liquids. GTL fuels are derived from natural gas, which has a lower CO2 intensity. They are also offer improvement in air quality and are non-toxic, odourless, readily biodegradable and have a lower hazard rating. Gareth Day will later share an exciting fuel switching project happening at our Criggan asphalt plant. And finally, in the carbon emissions hierarchy, carbon capture. Deploying carbon capture, utilisation and storage, or CCUS, is of uttermost importance for the cement industry, since 2/3 of the direct emissions come from the calcination of the limestone into the cement clinker during the burning process in the cement kiln. Because we cannot change chemistry, these emissions are unavoidable. CCUS is therefore not only a necessary prerequisite to achieving net zero emissions in our sector, it is also pivotal for the transition as we continue to innovate. With this technology, we can move towards offering carbon captured net zero products and have the potential to completely transform cement production, enabling a whole new level of CO2 reduction. Later, we will be joined by Gareth Price, our Carbon Capture Project Director, for a more detailed presentation on CCS in Heidelberg Materials and an update on our exciting Padeswood Carbon Capture project. So, it's so important to understand and engage at all stages of the carbon mitigation hierarchy to successfully transition to net zero. The emphasis of the mitigation hierarchy is on prevention, followed by reduction, then substitution of emissions with other energy sources. Only after this can the remaining emissions be eventually removed through carbon capture and storage. So now I'm going to be joined by the fantastic Nina Cardinal, who is going to take us through some innovations which we've been working on recently in our pursuit to net zero. Nina, good afternoon.
Thanks, Marian. Good afternoon, everybody. I'm Nina Cardinal, the National Technical Manager for the cement business line of Heidelberg Materials in the UK. I'm going to talk about an example, or give you an example of the circular economy in practice, the potential which recycled concrete paste has. This is a development from our colleagues in Germany. I'm going to present in 5 parts. I will first share some thoughts about the circular economy, and then introduce the development, which started as so many developments in the lab, about how we mineralize CO2 in recycled concrete paste. And by the way, as of now, I will probably just say RCP rather than recycled concrete paste each time. I will then move on to the pilot developments, following the lab developments, and where we are now in terms of commercializing this development before I conclude with some remarks at the end. While preparing for this presentation, I came across a study by the European Union known as Beyond Growth. And in there I found the figure that at the moment, the contribution of recycled materials back into the economy, substituting for primary raw materials, was less than 12% in the EU in 2021. And we still have an over-reliance on economic growth as the main policy driver, and we use GDP as a key economic measure. And we really need to recalibrate and move away from economic growth and GDP towards sustainable prosperity. That means we need to decouple economic growth from increased CO2 emissions through delivering innovations which are greener and more sustainable. And that's what you can see here in those graphs on the left. The blue lines is the GDP growth since 2010 to 2019. And as you can see, it was significantly higher in China and in India than in the EU and the USA. And then the red and the green line are the carbon emissions associated with production and consumption. And as you can see, as GDP grows, those emissions still grew in China and in India as well. However, there is really hope here, because when you look at the EU and the US, while we had some economic growth, it was modest, but at the same time, the carbon emission in those two areas actually reduced. And that's where we need to go. We need to reduce those further while we still have growth. What you see here is the cycle, the traditional cycle of concrete recycling. So when concrete comes to the end of its use and it's demolished, some of it might be stockpiled, but most of it is being recycled into recycled concrete aggregates, some of which go back into concrete. But there's a limited amount which we can use of those. And the concrete fines, can be used in the cement production as a raw material. And in fact, the cement standard has been updated. There's a new part to it now which allows also the use of those fines as an SCM, but it's totally inert, so it doesn't actually contribute to the strength development. If we now move on, and that's what I will be mainly talking about this development, you still have the traditional cycle down here before, but the recycling step is now, we call it now selective separation. It creates sand and aggregates separately, which can be used, and you will see later, up to 100% in concrete, and it produces a recycled concrete paste, the RCP. This RCP we can actually carbonate with the emissions from our cement works, or it could really be the emissions from any industrial process which has CO2 in its stream. And this carbonated concrete paste can then be used as an SCM, supplementary cementitious material, because it's actually activated. So we reuse material and we mineralize carbon. That takes me on to now to the initial laboratory developments. What does it actually mean, mineralizing CO2 in RCP? RCP contains calcium oxide, and then when it reacts with the CO2 from the emissions from the flue gas, for example, it forms calcium carbonate. Calcium carbonate is a stable oxide. It has low solubility in water, and it's thermodynamically stable under atmospheric conditions. This means that the calcium carbonates, they actually provide therefore permanent storage for CO2. No presentation with a good SEM photograph. What you see here, this is a photograph of carbonated recycled concrete paste. The purple areas are the calcium carbonates, and they react when they're added to cement and hydrate. They react with the aluminates. And we also see a silica alumina gel forming, which is a pozzolanic material, which we know already from GGBS or fly ash, which again gives strength to SCMs. Looking now at the kinetics behind carbonating paste, what you see here is the level to which RCP has been carbonated under different levels of CO2 concentrations in the gas. And what you see is that after 120 minutes, even at low concentrations, as long as it's about 10%, we almost saturate the RCP with CO2. This is an important finding because it means we can be using almost any gas which contains CO2. It doesn't matter how highly concentrated it is in the gas. Moving from the lab to pilot developments, first of all about the selective separation. This is a traditional recycled concrete, and what you have here is the cement paste still adhering to the aggregates, which means that the aggregates themselves don't give a very good performance in concrete. They increase the water demand, and the fines from this process are also not particularly good for use in concrete. That is why most of this material ends up, for example, as road base or in earthworks, which is not true circularity because it's really being downgraded from its original use. This now moves on to this selective separation process, which was invested in as part of a funded project in Germany, where we installed a plant in Berlin in 2021, which processed about 100 tons of crushed concrete per hour. So after the traditional crushing, there is an additional fine grinding stage. It's a low energy treatment, and that creates separately the aggregates, the sand, and the recycled concrete paste, as you can see here. These are the aggregates from this process and the sand. They are incredibly clean, and this really allows them to be 100% reused in concrete. And then on top of it, we get this recycled concrete paste, which is rich in hydrated cement and which we can carbonate. From the selective separation, we then took this paste to industrial pilots. The first one was carried out at our cement works in Brevik in Norway in 2020, where we have a dry scrubber associated with the cement plant, which you can see there on the top of the slide. And we created 2 times 20 tons of carbonated RCP. Then we repeated this actually in our own cement works in the UK in Ribblesdale in 2022, where we also have a scrubber, but it's a wet scrubber, and we produced 15 tons there. And then we did a smaller trial in Germany on a Polysius flash reactor. What have we shown by this? It was really showing the feasibility of being able to use raw kiln gases to carbonate the paste, and that we achieve a very high degree of carbonation even at low temperatures and at normal pressures. This now takes us really to the next step in this development, into scaling this up. While I'm speaking, this industrial demonstrator is currently being built. It will have a capacity of processing about 1 ton per hour of RCP, and we think we will achieve about 80% carbonation in less than 30 minutes with relatively low energy demand. And in this process, we will use about 100 to 150 kilograms of CO2 per ton of RCP. We will be using the RCP from recycling plants like the one I showed before from Berlin, and this particular demonstrator will be integrated into one of our cement plants in Poland. We will initially use it to optimize the process and collate data associated with it so that we can still improve the design. It's due to be commissioned in the second half of this year. And this is the one slide where I want to share some results. What you see here is a typical graph of compressive strength on the y-axis after 1, 2, 7, 28 and 90 days of cement mortar. We have made cements with 40% replacement levels in this case. The grey bars represent 40% replacement with just simple limestone fines. The orange bars are from synthetic recycled concrete paste, and then the blue ones are from these industrial trials which I talked on before. And as you can see, even at the very early age of 1 day, the carbonated RCP has a higher strength than using just limestone fines. And this becomes even clearer so at 7 days and at 28 days, where there's a significant improvement in strength development, demonstrating that this recycled carbonated concrete paste is a true SCM with high levels of reactivity. What is the next step for us in terms of commercialization? What you see here is now the next industrial-sized plant, which is being commissioned currently in Poland, very close to our cement works there, and in an area where there is recycled concrete available as well. And we will be operating there with over 100 tons of crushed concrete per hour, and will then use the concrete paste from this process to use in the demonstrator to carbonate it. So in summary, I hope I've been able to demonstrate selective separation and enforced carbonation. The advantages are really that it addresses both our challenges, the one of the CO2, but also having to maintain our natural resources by recycling. The process enables CO2 sequestration, which means permanent storage of the CO2, and the aggregates and the sand which we create in the process can actually be 100% replacement in concrete. The carbonated RCP exhibits very high reactivity with good early strength as well. And I haven't shown it in the presentations, but we have also done trials with mixes where we used CRCP and GBS and calcined clays, and we get further synergies there, even better strength development. The process has the potential to be scaled up. It is a low energy process, and as you have seen, the technology is really now matured so that we can move to the next stages of industrial pilots, and it is an example of true circularity. Like all new developments, it comes with its own challenges. One of it is about our mindset, really. How do we deal with concrete demolition waste? How can we use it better? We will clearly need CapEx requirements for those installations, for the selective separation plants, and for the carbonation reactors, and also the logistics associated with it. And then, as so often with new SCMs, so far we have limited experience in terms of the long-term performance in concrete, i.e. the durability performance. But again, work is ongoing to obtain results of concrete durability with CRCP. Thank you very much.
Great, thanks Nina. Some really, really exciting projects and innovations. And I know you're going to be back later to talk to us about Evo Zero. So please remember to ask any questions around any of the presentations on the Slido code. The QR code should be now on your screens. So as I mentioned earlier, the reduction of carbon emissions is fundamental to achieving net zero. So I'm now going to be joined by Gareth Day, our Asphalt Managing Director, to talk to us about an exciting low carbon product his team has developed in collaboration with National Highways and Atkins, and also about his business, how his business is aiming to substitute high carbon emitting fuel in his asphalt plant.
Good afternoon, everybody. I'm Gareth Day, Managing Director of the Heidelberg Materials Asphalt Division. Asphalt is already one of the most sustainable construction materials available. It is extremely durable and 100% recyclable, with worn-out surfaces able to be reused in new asphalt, which may also contain other recycled content such as glass or recycled aggregates. The embodied carbon per tonne of asphalt is typically between 40 and 75 kilograms, depending upon the type of asphalt, raw materials, transportation, and production processes used. Of these, emissions from the energy used in production and the raw materials used are by far the largest contributors, with emissions associated with the laying of the asphalt only around 4 to 6% of the total embodied carbon of the finished material. As an asphalt producer, we think about the carbon footprint of the asphalt we produce and lay on the road network in terms of scope 1, 2 and 3, and importantly, life cycle emissions. Scope 1 covers the emissions in the production of the asphalt, mainly fuel used to heat up the product. Scope 2 covers electricity used in production, and Scope 3 covers the embodied carbon in the raw materials used in asphalt production. Increasingly, we are working with partners to also reduce the carbon impact of road maintenance by considering the life cycle, making roads more resilient and reducing interventions over the life of the road, and therefore whole life carbon emissions. In terms of the product itself though, some of the specific ways we're reducing carbon emissions from the production of asphalt include switching to low or zero carbon fuel sources, including hydrogen, which affects scope 1. Producing asphalt at lower temperatures using our ERA warm mix asphalts affects scope 1 as well. Increasing the percentage of recycled asphalt planings within the mix will affect scope 3. Using lower carbon biogenic bitumen substitutes in our carbon lock asphalt affects scope 3. We will present 2 innovative projects that we are currently implementing to deliver carbon savings in all of these ways. Firstly, the A2 and A34 trial of our innovative carbon lock product, and secondly, our hydrogen project at Criggian Asphalt Plant. Following our success in 2023 of our A30 trial with the first use of a biobinder asphalt in a thin surface course on the strategic road network, we're now moving to phase 2, working collaboratively with National Highways and Atkins. We're undertaking further trials on the A2 and A34 using a polymer modified biogenic binder in combination with our ERA 140 asphalt mix asphalt, and importantly, a recycled asphalt planings content of 30% in a thin surface course. This high wrap content material will use Shell's Carafalt Ultra Carbon Sink biobinder. The use of our ERA 140 warm mix asphalt will contribute to reducing our scope 1 emissions by around 3%, while the biobinder will reduce scope 3 emissions by around 23%. Each trial will include around 500 tonnes of carbon lock asphalt, with the use of biogenic material absorbing and storing CO2 throughout its life, even when it is recycled, reducing the carbon emissions associated with asphalt by around 26% across scope 1, 2 and 3 in total. These will be the first trials of their kind on the strategic road network, combining our biobinder product, Carbon Lock, our era warm mix asphalt and high wrap contents of 30% in a clause 942 thin surface course. The asphalt will be produced at our Allington and Appleford plants and laid by Heidelberg Materials Contracting. The trial sections are undergoing extensive laboratory testing and are being closely monitored to see how they fare compared with the control sections using standard polymer modified bitumen asphalt. The carbon reduction benefits of the project versus a standard asphalt can be summarised as the following. Era warm mix asphalt, scope 1 reduction of 2.4 kilograms per tonne of CO2. Recycled asphalt planings at 30% is a scope 3 reduction in CO2 per tonne of 6.3 kilograms. Carbon Lock asphalt, which substitutes a portion of the bitumen with biogenic material, results in a scope 3 reduction of 12.5 kilograms of CO2 per tonne. In total, that will amount to a reduction of CO2 of approximately 20.2 kilograms of CO2 per tonne of the total scope 1, 2 and 3 embodied carbon. Here is a short video from Umesh Parajuli of National Highways describing the project and its benefits.
My name is Umesh Parajuli. I'm chartered and certified pavement engineer, currently working with SES pavement team in National Highways. I think the decarbonization is everyone's interest. It is not like, the one organization or one government. Even this is the interest for the entire world. The every governments now they are focusing, because this is linked to our future generation, links to our sustainability. This is linked to everything. The National Highway manage, maintain, and operate the England's strategic road network, which is principally includes the motorway and trunk road. And UK government has its ambitious policy to achieve net zero in 2050, and everyone within this country have a responsibility to support that. In order to support this, the policy. In 2021, National Highway has published its net zero plan for strategic road networks at various stages. For example, net zero by 2030 at corporate level, which includes the emission from its internal vehicles, and then the emission from the offices, etc. Similarly, like the net zero by 2040, which is basically targeting the construction and maintenance of strategic road networks. This includes various stakeholders deliver the work within the National Highway, the strategic network. Similarly, the 2050 net zero 2050, which is basically the public level emissions. So traditionally, the asphalt, which is the bitumen, is based on the fossil fuels, and so we are now, with the various innovative product like the biobinder, we are trying to reduce the traditional bitumen, and then we believe the biobinder will help the reducing the carbon significantly. So in 2023, with support from one of our important stakeholder, Heidelberg, to trial the biobinder in A30, which we trial, and then so far the the performance is a brilliant, like that. And then in the second phase now we are trying to trial more of the biobinder with other technology, like the biobinder in the warm mix, biobinder with the increased rate of reclaimed asphalt. So we received the huge support from the Heidelberg. Actually, to be honest, the first the proposal to trial biobinder which we received from Heidelberg, it was fantastic. So and the Heidelberg's team, the operation team, so everyone were very cooperative, and as a result of our collaborative working with the Heidelberg National Highway, the operation team, including the consultant, the Atkins. So we managed to deliver the trial on A30, which was fantastic. Is performing very well. And then based on that experience, now we are planning for the trial on A34 and A2. The head of the technical, Adrian Hadley, who is a fantastic, very experienced, very knowledgeable, is providing a lot of support to achieve this trial. And then in the second phase also, we are expecting to receive the similar level of collaboration.
Thank you, Umesh, for talking about the importance of this project from National Highways' perspective. It's a great example of collaboration with forward-thinking partners like National Highways and Atkins to help us on our path to decarbonisation. I'm now going to talk you through the second topic, describing the use of hydrogen in asphalt production. The hydrogen project at Criggian Asphalt Plant has been running since spring 2022. It's a key step towards the decarbonisation of our asphalt business. The project's main aim is to assess if hydrogen can be used at industrial scale to manufacture asphalt more sustainably. The use of hydrogen for asphalt production has the potential to eliminate 100% of a plant's Scope 1 carbon emissions. This would reduce asphalt embodied carbon by up to 50% overall. The current demonstration phase complements work that has already been completed at feasibility stage. The main outcome of the project will be a 4-week demonstration at Criggian Asphalt Plant in the first half of 2025 to replace processed fuel oil with hydrogen on one of the asphalt plant burners. The Department of Energy Security and Net Zero has committed multi-million-pound funding to this demonstrator phase that we're completing with our consortium partners EDF and Vulcan Burners. Here is a short video to explain more.
Good afternoon, welcome to Criggian Asphalt. My name's Steve. Everyone will probably know me here as Skilly. I've been here coming on 25 years. We're an asphalt plant. We produce the blacktop that you have probably driven on today and probably may or may not know an awful lot about. It's basically aggregates with bitumen added to it to make the surface that we drive around, all over the world. Behind me is a plant that basically is a 35-year-old Brahma Mela plant. There are 2 plants, both capable of doing around 55 tonne per hour with 35% RAP addition. We're currently using a PFO fuel in both our main burners. Obviously that has an impact on the carbon footprint. So over the past couple of years we've been looking at a feasibility study of running our burners on hydrogen. Obviously with a view then to reducing our burners to a 0 carbon footprint target. And we're hoping to trial that early 2025.
Hi, my name's Rachel. I'm on the graduate scheme in the Sustainability team. One of the projects I've been working on is the Criggian Hydrogen project. I'm here today at Criggian Asphalt. The purpose of the project is to convert the 2 burners here at Criggian to be able to run on hydrogen. Hydrogen is a low carbon fuel, but when it burns, only produces water, unlike other fuels, which will also produce CO2. You may have heard of the hydrogen rainbow. The hydrogen rainbow is different colours of hydrogen that refer to how the hydrogen was made. 95% of the world's hydrogen is grey hydrogen. This is hydrogen that's made from natural gas and has a higher carbon footprint. When we talk about low carbon hydrogen, we're talking about other colours, such as blue, which is natural gas with carbon capture, green, which is hydrogen generated from green electricity, or pink, which is hydrogen generated from nuclear electricity. There are many other colours, but these are some of the ones that we've been looking into and investigating the supply chain for our asphalt plants. At Criggan, we're hoping to achieve a world first. We're converting both burners to be able to run on hydrogen. We're working with Vulcan Burners, who are designing a new burner, and we've been out to Northern Ireland to see their test setup. Hydrogen burns with an invisible flame, and we were able to see their burners in action running on hydrogen, which was really exciting. This is an 8-week trial to understand the feasibility of burning hydrogen for asphalt production. As part of this study, we're working with hydrogen producers to understand when it would be economical to burn hydrogen on burners like the ones at Criggan.
So yeah, Heidelberg carbon neutral burners, exciting times ahead. Glad it's happening at Criggan. Can't say that I'm frightened by it. We like the challenge, some good learning to be had going forward. Let's hope that we become carbon neutral on both of our burners.
Thank you for your attention, and I'll now hand you back to Marian.
Thank you, Gareth. And really, two really great projects helping the asphalt business to achieve net zero. And I'm very excited to see how the hydrogen as a fuel project develops in the next few months. Please remember to ask any questions again from the presentations using the Slido QR code, which should be on your screen now. As I mentioned earlier, CCS plays an important role in the carbon mitigation hierarchy. So we are now joined by Gareth Price, our Project Director for Carbon Capture. But just before I hand over to Gareth, a quick poll on the Slido app. How much carbon do you think Heidelberg Materials will capture by 2030? So quick poll, and hopefully Gareth is going to give you the answer during his presentation. So over to Gareth.
Thank you, Marian, and good afternoon to you all. I'm Gareth Price, Carbon Capture and Storage Director here at Heidelberg Materials. I've been working in the cement manufacturing industry for a long time, managing all three of our plants at Ketton, Padeswood and Ribblesdale. I can honestly say that we're currently going through the most exciting period ever. As Marian showed earlier, the manufacture of cement involves the application of heat to limestone to trigger its conversion to clinker through the release of its CO2. This chemical reaction is responsible for 70% of our emissions, and the remaining 30% is due to the fuel that we use to heat the limestone to over 1450 degrees centigrade. The clinker is then mixed with gypsum and ground to a fine powder. That is the cement we all know today. As a company, it's only natural that we focus on the biggest area of emissions, the 70%. Over the next few minutes, I'm going to take you through what we're doing to capture and store those emissions at cement plants throughout the Heidelberg Materials Group across the world. As a group, we are planning to invest billions of euros in carbon capture technologies by 2030, with the ambition of capturing 10 million tonnes of carbon, preventing it from being released into the environment. Over £600 million of that will be spent at our Padeswood Cement Works here in the UK, which I'll cover in more depth shortly. Within Europe, the biggest project is happening at our Slite plant in Sweden, which comes online in 2030 and is designed to capture 1.8 million tonnes per year. This is post-combustion carbon capture using amine technology, and the heat required will be from the kiln system and heat pumps. The CO2 will be liquefied and transported by ship to storage facilities in the North Sea. I do understand that 2030 sounds a long way off, but we have plants which are scheduled to make zero carbon cement much sooner. In fact, our Brevik plant in Norway is scheduled to be manufacturing carbon captured cement in 2025, and we will see later this afternoon how the benefit of that is being made available across Europe. The plant is one of the first in the world to come online, with the aim of removing 400,000 tonnes of carbon. It is a post-combustion carbon capture plant using amine, with all of the heat required coming from the kiln system to remove the CO2, then converting to a liquid, loaded onto ships and transported out to sea for underground storage. Looking outside of Europe, we see some even bigger carbon savings targets. At our Mitchell plant in Indiana, USA, around 2 million tonnes per year will be captured and stored from 2030, and a further 1 million tonnes a bit further north in Edmonton, Canada, which will be ready in 2029. It's really important that we recognise that carbon capture and storage technologies are in their infancy, and there is not yet a one-size-fits-all approach. Each country and each plant has its own unique circumstances and requirements. These are often due to their location, the availability of storage facilities for the carbon that has been captured. At our Padeswood cement plant, we are very fortunate to be positioned in one of the regional industrial clusters, where we are part of the HyNet cluster. HyNet is a network of businesses focused on helping industry decarbonise by capturing their emissions and storing them under the Irish Sea. This video helps explain how this works.
All the things we use every day.
From the food we eat
to the toiletries we buy.
To the bins and recycling we put out.
All have a carbon
footprint.
All your personal, everyday essentials.
Require energy to make and rely on fossil fuels. But what if there was a way we can carry on doing the normal everyday things we've always done?
And still be carbon neutral.
With the HyNet project, work has already begun. HyNet allows energy-intensive industry to switch to low-carbon hydrogen. And when that's not possible, we capture and store the carbon emissions from industrial plants. Through hydrogen power and carbon capture technology, HyNet are working towards ambitious goals, ensuring energy security, growing the economy, and leading the way on a global mission to decarbonise. We'll be creating and protecting highly skilled jobs all over the UK.
So now imagine all the little things we love about life
Can stay as they are. Because we believe that there's a future
where power is clean
and safe for everyone.
HyNet, working together for a zero carbon future.
To play a full role in the HyNet scheme, we're investing over £600 million in our cement plant at Padeswood, installing a full carbon capture plant. The scale of the project is enormous. The plant has been producing cement for almost 80 years, and retrofitting a whole new, highly technical capture plant onto it presents huge engineering and logistical challenges. However, the benefits of doing so far outweigh the costs and the work involved, as we will be capturing up to 800,000 tonnes every single year. When the plant comes online in 2028, it will be the first zero-carbon cement works anywhere in the UK, which I feel personally a huge sense of pride about. So, what process are we going to be using there? We're going to be using a similar system to the one being used at our Sleater and Brevik plants, as discussed earlier, whereby we capture the emissions using amine technology, and we will also install a combined heat and power plant for the heat and energy requirements. The difference at Padeswood is that we will be compressing the CO2 and pumping out to sea as a gas, not a liquid. There will also be no storage at the plant. It will be compressed and pumped away as the CO2 is captured. I do realise that this has been a whistle-stop tour of what we as a group are doing to become the world leader in zero-carbon cement manufacture, investing billions of euros worldwide, with Padeswood receiving a significant proportion here in the UK. I'll now hand you back to Marian for the next part of our carbon capture story.
Thanks, Gareth. It's quite clear that we as a group We have got some really, really exciting projects underway across the world with some huge investments already been made and some more in the pipeline. I think it's really important to remember that there are several technologies available for these carbon capture plants and that they are all new and evolving. The investment in these projects are significant and the lead time for bringing them online are normally many years. So it's essential for us to be exploring other techniques and technologies as they become available. So we're now going to hear from Elliot and Rachel again about an exciting project at our Ketton Cement Works. Hi, Elliot.
Hi, thanks, Marian. Good afternoon. I'm Elliot Welbelove. I work in the Sustainability Department as Carbon Innovation Manager for Heidelberg Materials UK. I've been in the industry for almost 12 years now, working in various roles, predominantly within cement. My current role covers all business lines, and my main responsibilities are leading and driving net zero ambitions across the entire business. I help source and manage government-funded schemes and coordinate various innovative projects within the business. As we've heard from Gareth, CCS is a key decarbonisation lever for capturing the 70% of unavoidable carbon dioxide emissions generated from the chemical reaction that occurs when making cement. But we're also exploring all sorts of other initiatives. On a smaller scale to Padeswood, we have a collaborative project with a company called Sea Capture, who have developed innovative carbon capture technology. Our joint government-funded scheme, CCUS 2.0, has two main parts. The first part of the project has produced a feasibility study that explores engineering designs for a full-scale carbon capture plant at Ketton Cement Works. The study has helped identify bottlenecks at the site for carbon capture technology. For example, how CO2 could and would be transported from site into storage. The study has assessed two different carbon capture scenarios. The first scenario explores how we can incorporate burning waste to provide heat and steam for the capture process. This concept could significantly reduce the overall cost of carbon capture technology. The second study scenario explores how waste heat can be used on site to power a smaller capture plant, which could be an intermediate step towards full capture. The second part of the project will demonstrate if Sea Capture's innovative technology is suitable for the cement industry. In order for this to be proven, a small-scale demonstration unit has been built and installed on site at Ketton. This miniature carbon capture plant is connected to our stack flue gas. We will then operate the small unit in real-world conditions for around 1,000 hours, gathering data on the performance of the capture technology. We're now going to share a short video on our Sea Capture project at Ketton.
I'm Elliot Welbelove, Carbon Innovation Manager for Heidelberg Materials UK. Today we're at Ketton Cement Works, where we produce ordinary Portland cement. As you can imagine, the production of cement is very carbon intensive. Therefore, we need to find innovative solutions in order to reduce our carbon footprint and our impact on the environment. Here at Ketton, we're taking part in a project with Sea Capture, looking at a new innovative solution for carbon capture. Our Sea Capture project at Ketton is a field trial in order to demonstrate how effective Sea Capture's technology can capture CO2 and potentially reduce the heat required in the carbon capture process. We've chosen Ketton as a site for the Sea Capture trial because it's classed as what's known as a dispersed site. Therefore, we're not necessarily very close to a pipeline network where we can transport CO2. Therefore, we will potentially look at transporting CO2 by road or rail to the closest storage. One of the key actions for our 2030 sustainability commitments is to carry out feasibility studies for carbon capture at both Ketton and Ribblesdale. The Sea Capture project has helped us achieve our 2030 commitment for a feasibility study at Ketton. Our project is part of a consortium which involves other hard-to-abate sectors such as glass manufacturing and energy from waste.
Hi, my name's Rachel Morse and I'm a Sustainability graduate at Heidelberg Materials UK. One of the projects I've been most involved with is the Sea Capture project here at Ketton. We take flue gases from our stack and pass it through the unit, which contains Sea Capture's novel solvent. The solvent absorbs the CO2 and then desorbs it as a pure stream. We then mix the CO2 back with our flue gases and release it up the stack. The purpose of the trial is to show the multiple cycles of the absorption and the desorption of CO2, and this allows us to see how sea capture's novel solvent performs in real-world conditions. The unit will capture and release 50 kilos of CO2 a day. The CO2 used for this trial is fairly small in relation to the CO2 produced at Ketton. However, the trial will show us how the technology can be scaled up to do a full-scale carbon capture plant in the future.
Hello, my name is Tom White. I'm the CEO of Sea Capture.
So Tom, could you tell us what this project's all about?
Yeah, sure. This is the Department of Energy Security and Net Zero's Accelerate CCUS project. It's all about commercialising next generation technology as quickly as possible. That's why it's called CCUS 2.0. And what we're doing is we're testing our proprietary solvent on your real world flue gas, measuring the performance of our solvent which captures the CO2 so that we've got the data we need to design a commercial scale unit.
What does Sea Capture's technology actually do?
Well, Sea Capture's technology is all about the chemistry. We've got a solvent which binds onto carbon dioxide, preventing that carbon dioxide from going up into the atmosphere. So we capture that carbon dioxide, compress it for sequestration into offshore geology. Now, our technology is particularly suited to harsh industrial flue gases which have got high levels of contaminants and particulates. It makes it easier for us to address those really hard to abate sectors like cement, waste to energy and glass.
How important is your technology for real hard to abate sectors like the cement works?
No, it's absolutely vital, Elliot, because what we want to do is to put second generation technology in as quickly as possible. We don't want to lock ourselves into old technologies that take too much energy or use toxic compounds to capture that carbon dioxide. So bringing those technologies to market quickly is absolutely vital, not just for people like yourselves who've got emissions, but also for the UK economy. We need to make sure that we maintain our long-term international competitiveness using the best-in-class carbon capture technologies.
My name's John Gordon. I'm a CCS Innovation Programme Manager at the UK's Department for Energy Security and Net Zero. Following on from Sea Capture's first trial unit at Pilkington NSG in St Helens, it's great to be here today at Heidelberg's Ketton Cement Works. The development of next generation carbon capture technology, funded through the CCS Innovation 2 programme, is key to capturing process emissions from the hard to abate industrial sectors such as cement, glass and energy from waste. As a business, one of our key goals is to make carbon neutral cement here at Ketton. We've been really pleased with the Sea Capture project because it's provided one of the critical steps towards our overall decarbonisation journey.
As you saw in the video, it's been an exciting journey so far. We've had the opportunity to collaborate with other hard-to-abate industries, and the initial results are promising. Heidelberg Materials has funded around £140,000 into the project. If the demonstrator proves that this technology can be used in our industry, it could reduce the cost of carbon capture, not only in Heidelberg Materials, but also worldwide. At this moment in time, we don't know if this is going to work. However, as a business, we need to take controlled risk in order to enable innovation. The future of the project is yet to be determined. At the very least, we've created a future testbed that could be utilised by future startup technology companies coming into the market. A project like this keeps our decarbonisation options open, while concurrently providing a crucial resource for innovative technology providers. So far, this project has allowed collaboration with other hard-to-abate sectors, manufactured a proving ground for new innovative technology, and provided insights as to how we can decarbonise a dispersed site like Ketton in the not-too-distant future. The demonstration unit will be operational in a couple of weeks, and we're eagerly anticipating the initial results.
Great. Thanks, Elliot, and thank you, Rachel. The Sea Capture project is a really good example of how multiple industries can work together in addressing the challenges posed in reducing carbon emissions. In this case, waste to energy and glass manufacturers, alongside us as cement producers, are working in partnership to determine whether the technology developed by Sea Capture is effective and scalable. The unit that you just seen on the video, we're hoping, Elliot said in a few weeks, we're hoping for it to go live next week. So it's going to be really exciting to see how that progresses. Hi, welcome back. Thank you for joining us for the second part of our Let's Talk Sustainability event, where we'll be covering our strategy for decarbonisation. So far, we've heard about the options for low carbon products in our cement, concrete and asphalt businesses, the exciting UK's first fuel switching project at our Criggan asphalt plant, the carbon capture projects that our group are investing in worldwide, an innovation trial we're taking place at Ketton. Gareth mentions the world's first carbon capture plant in Brevik and the availability of fully carbon-free cement. I'm now going to be joined by Nina again, who will take us through how we're bringing this product to market, followed by how we're providing accurate carbon data with our materials to help you as customers and supply chain make decisions to decarbonise your projects. Welcome back, Nina.
Thank you very much, Marian. Gareth introduced before all the various carbon capture projects ongoing within Heidelberg Materials, and the first one is due to become live next year already. At that point, we will have a net zero concrete cement available, and we have called it Evo Zero. That's what I want to introduce to you now. So just to go back to what Gareth spoke before, here's a timeline of the many carbon capture projects of Heidelberg Materials. At the top you see those within our own company, and this is the one which stands out. It's the carbon capture project at Brevik in Norway, which is due to come online next year already. And at the bottom, and then follow on the various other carbon capture projects, our own one here in Padeswood around 2028. At the bottom you would see when we anticipate our competitors will have their first carbon capture plants up and running. And there's at least a 4-year gap between our first plant coming up and online and then the next ones. So Brevik will be the first one to produce net zero cement or net zero clinker. It is a small amount, as is shown here. It is only about 1% of the cement demand in 2025 in Europe, but nevertheless we have to start somewhere. How will it work? So we will be capturing about 400,000 tons of CO2 in Brevik. From this, we will have about 500,000 tons of net zero clinker. The capturing of the CO2, the amount we are capturing and the emissions are being certified by DNV and are also accounted for by our blockchain system. Each ton of CO2 at Brevik and later at the other projects as well will be net zero clinker and will be cleared only once. So there will be no double accounting there. Given how close we are in the UK to Norway, we will actually be able to take physically net zero cement from Brevik for construction projects in the UK. And it's not new to us. We have previously imported cement from Norway into the UK. Some of you on the call, our clients will have projects also further afield. For these more distant projects, the carbon savings which we make in Brevik, we can virtually transfer them to one of our sites in the other parts of Europe or even in the world, and that's how we can still benefit from our Evo Zero cement. So just to summarize this again, how will we be able to give credible certificates of our Evo Zero product? It's a 3-layered approach. First of all, we make sure that there is no double counting. DNV have already reviewed how we intend to account for the CO2 and have confirmed that there is no risk of double counting. Secondly, then in terms of EPDs, initially we will add a note to the EPD of the Norway cements, which will account for the CCS reductions in the note. Hopefully by the end of 2025 we will actually be able to account for this carbon saved in the main body of the EPD. At the moment this is not possible because actually the standards have not developed yet. Discussions are ongoing, and on top of this we actually need to produce the cement to be able to put it into the main body of the EPD. And then, as mentioned before as well, there's additionally the blockchain mechanism, which brings transparency to our customers and to the public as well, how we deal with the CO2. I hope you're as excited as we are about Evo Zero cement, and in a year's time it can be reality for you if you're interested in a net zero cement. This is still a year away. So a bit closer to home and to the now, I just want to talk about how we currently make our carbon data visible to you and the tools which we have available for our customers. I'm here mainly talking now about concrete rather than cement. But this slide here shows how these are intrinsically linked. This is the embodied carbon for a C35 concrete, in this case made just with CEM1, so no GGBS. The total embodied carbon in this concrete is about 260 kilograms per cubic meter. And 90% of this, as Simon mentioned earlier, come from the cement. So that's the major contributions. The other contributions of the embodied CO2 in concrete comes from the haulage, the aggregates, the admixtures, and then the operations at our batching plants. How do we account for this carbon? We work to the standard which is EN 15804. It covers the environmental performance of individual products, in our case the product being the concrete. And it is the basis for environmental product declarations. And within this, most of you are interested in the global warming potential. That is really the number of the embodied CO2. This is about the individual product. In addition, there is now a new standard past 2080. And we as Heidelberg Materials in the UK are one of the first companies in the UK in heavy building materials to be certified to this standard. And this is about managing the carbon in buildings and infrastructures. So it actually looks at the whole supply chain rather than just one product. And where we come into it is about the early engagement with our supply chain, with our customers, with our clients to ensure that we have the lowest carbon solutions for buildings and infrastructure. When talking about carbon in cement and concrete, it's really important to understand the concept of gross versus net emissions and accounting for this. So the embodied carbon of cement includes the emissions from the fuel burned to heat the kiln, which we talked before. When we talk about gross emissions here, that includes all the emissions arising from the combustions of both the fossil fuel and the waste-derived fuels, which we also sometimes call alternative fuels or secondary fuels. When we speak about net emissions, that omits the emissions from the combustions of the waste-derived fuels. And that makes quite a significant difference. That's why it's important to understand it. That's what you can see in this table here. These are numbers from EPDs, from the Mineral Products Association, so they are industry average numbers for a CEM1 EPD. If we account gross, so if we include all the emissions, we have 840 kilograms of CO2 per ton of CEM1. If we only look at the net emissions, i.e. exclude the emissions from the waste-derived fuel we burn, this reduces to 754 kilograms per ton of cement. The MPA recommends, and we agree with this, that we should be using gross values. But you need to be aware that some cement suppliers report by default the net emissions. We, as Heidelberg Materials Concrete, we will quote our carbon data using the gross cement value. We will also show the net value. That is really for you, for our customers, for our clients, to be able to compare it and to make sure that you don't compare apples with pears. In terms of calculating the carbon emissions associated with a product or embodied in a product, this is done to this EN 15804 standard, which I mentioned before, which has several modules for the carbon, upfront carbon and up to construction. Then the orange part, once building or infrastructure is in use, the end of life, and in fact there are further modules now for the recycling stages as well. For the concrete itself, it is really only this part here, the product part, the stages A1 to A3, which are relevant. This is the so-called concept of cradle to gate, the gate up to when the concrete leaves our batching plants. And it is for those stages that we calculate the global warming potential. Here is an example of, again, an industry standard EPD from the MPA for a concrete. And it is this number. The document itself is about 13 pages long, and most people are interested just in the one number here, which is the global warming potential here for A1 to A3. And for this particular concrete, the C35 concrete made with CEM1 only, this adds up to 272 kilograms of CO2 per cubic meter of concrete. Fairly similar to the number I showed at the beginning as well. We compare our embodied carbon in our concrete to the benchmark which has been created by the UK Low Carbon Concrete Group, and this was published last year in September. This graph exemplifies this benchmark. So what you have here at the bottom are the different strength levels of concrete increasing in that direction, and here on the y-axis you have the embodied CO2 associated with those concretes. The very bottom line would be really market leading. And then as it increases, but at a level A, it's still a very low embodied carbon up to level F. This scoring system was devised on industry data, and in fact it includes a lot of our own concrete data which was inputted to get to these benchmarks. And this system again uses gross cement carbon values, and that's why clearly we also can compare our data against this particular graph. So if you order concrete with us at the quotation stage now, we can give you an indication of the embodied carbon we expect for the particular concrete you're ordering. The example here shows a concrete, a C40 concrete. In this particular case, actually a C3A concrete, i.e. made with GGBS. And the embodied carbon in a cubic meter in this particular case is as low as 150 kilograms per cubic meter. And that would correspond to a very high standard and class A in the benchmarking system which has been developed by the Low Carbon Concrete Group. I hope that has given you an overview of how we present our carbon data, and to be sure that it is that you can trust this data, we can also show you where the information, the carbon information comes from when we calculate those values. Most of the input values do come from established EPDs, either our own or industry accepted EPDs. At the moment, only for the carbon associated with our concrete operations and with our own specific aggregates, these are self-declared numbers. But even those are currently being verified by Lucidians, so that we can also have certified values for those as well. I hope that that gives you some confidence in the values which we can declare to US customers. And finally, just 2 slides on another option in terms of being able to save carbon in concrete. I want to present to you the digital smart rock technology. It's a real-time technology. We have partnered with a company called Giatec. They produce the software and these sensors, and they allow for real-time monitoring of how your concrete matures by monitoring the temperature development as well. If it's calibrated and we can help with the calibration of this, you also then can follow the strength development in real time. How does it work? You pair the sensor with the app on your phone or on your computer. You then install the sensor on the reinforcement. It's a sacrificial sensor. The concrete is poured over it, and from then on you can monitor it on the app on your phone, how both the temperature in the concrete and hence the strength develop. Rather than speaking more about it, there will now be a short video which shows again how this technology works, and I hope this might be of interest to you as well. Thank you very much.
So thank you, Nina. It's been really useful in showing how the carbon information can be given and how it's been verified. As the video showed, Smart Rock wireless concrete sensors monitors temperature and strength gain every 15 minutes for up to 60 days, providing real-time data that can help you save time, money and carbon with no need for test cubes and no waiting for results. The system gives you the confidence to use our low-carbon concrete with higher cement replacement levels, cutting carbon emissions while speeding up time on site and allowing faster removal of framework. The Smart Rock technology is available now and has been used by Laing O'Rourke in a recent project. The site is exceptionally busy and congested, requiring the main contractor, Laing O'Rourke, to have an exceptional level of efficiencies to be able to achieve the ambitious project to the deadlines. Bespoke concrete mixes were developed to enable the fast-paced programme to be met, and cube samples were taken for each pour to show the early age strength gains. Only once the concrete had achieved the required strengths could the next stage of construction begin. The Heidelberg technical team provided a demonstration of its Smart Rock wireless concrete maturity sensors and the web platform, which Laing O'Rourke then implemented to collect real-time data for its in-situ concrete. In this case, not only was Laing O'Rourke able to meet the tight deadlines of the project, it was also able to take advantage of the enhanced data available, which showed it was significantly exceeding the required concrete strength. This allowed a change to the concrete design to be made, reducing the total cement content by replacing it with additional GGBS, which lowered the embedded carbon content of the concrete by about 10 kilograms per metre cube. This approach is expected to save more than 34 tonnes of CO2, the equivalent of planting 1,700 trees throughout the life of the contract. So we are now joined by Dan Evans, who is the Head of Sustainability for Carey's, and Simon to talk about the need of transparent carbon data from a customer's perspective. Dan has been with Carey's now for a year, helping to drive and deliver their ambitious sustainability strategy. He has been an environmental and sustainable professional in the construction industry for 15 years, working with principal contractors on multiple major infrastructure projects in the South East. More recently, in the last 5 years, he has started to focus more on corporate sustainability and decarbonisation strategies in his previous role as Head of Environment for Taylor Windrone and now Head of Sustainability at Carey's. Good afternoon, Daniel, and welcome back, Simon. So, Daniel, could you just take us through what your decarbonisation strategy is?
Yeah, so the Carey's group are made up of BDL and PJ Carey, so BDL dry lining division, and PJ Carey's are our civil engineering division, so we do reinforced concrete structures and groundworks. So we had realised quite quickly, obviously, we've got a big role to play in decarbonisation, so we developed a strategy, a full sustainability strategy, which we called the 3 C's strategy. So the first C being carbon, compliance plus, and then community. So our decarbonisation part is obviously focused on the carbon C, but it does thread through all of them. Back in 2019, we started to want to put the strategy more structured. So we set out our baseline and tried to identify our hotspots around where our key emissions were. That allowed us to think about what commitments we were going to make in the future, and that journey sort of took us on the route with the SBTI initiative. So we set out 3 targets out to 2030. So one for our Scope 1 and 2 emissions, which was 50% reduction by 2030 against the baseline year, and the same for our Scope 3 Category 1 emissions. And then we also had a third, which was 84% of our supply chain by emission to also be aligned to science-based targets. So that was to sort of focus our efforts around Scope 3 and try and make sure we were, and our supply chain were on that same journey. So in terms of our strategy for Scope 1 and 2, we're obviously quickly realised, and we probably already knew, but once we put the numbers in, that our biggest contributor to our business for our Scope 1 and 2, 95% of our emissions was around our diesel use. So that was obviously been a huge focus. So we're in the process currently of upgrading our fleet for more efficient vehicles. So that goes for our road-going fleet and also our plant. So this year we've improved the road-going fleet. We've had about 102 new vans and 40 brand new excavators as well, all with the sort of really good efficiency ratings. The machines especially, GPS enabled and telematics to help us improve efficiency, which obviously is going to improve diesel. Then we've also looked at the small tools. We use lots of small tools, so we're almost there now really. Most of our sites, very few now use fossil fuel small hand tools. We've got our own range in-house of battery-powered cordless tools. We're working with our hire companies as well to try and bring in innovation and promote it amongst our sites. Like yourselves, with our HGV fleet, we are looking at HVO, and our HGV fleet runs almost entirely on HVO. So we've really ramped that up over the last few years, which has made a really big impact on our carbon emission savings. And then, again, like you, we're looking at REGO tariff and sort of renewable energy tariffs for our Scope 2. And we're also in the process of just investigating for our facility sort of renewable installations. So that's Scope 1 and 2. Scope 3, it's largely around supplier engagement like this, trying to get better data from our suppliers to feed into our carbon footprint. But we also need to know to feed into our clients of innovative products, what we can start pushing out. All our clients come to us and they want to know what products are out there which are low emission. So we are trying to engage our supply chain as best we can to try and promote those products internally.
Brilliant.
It sounds remarkably familiar, that. I mean, some of those things that you're talking about are exactly the same things that we're talking about in Heidelberg. Are there any areas that you can see that conflict? Or I suppose the opposite to that is, where can we work more closely together?
Yeah, I definitely don't think there's much conflict going on. I think the fact that you're aligned to the SBTi targets as well, that's obviously straight in there with our target for our supply chain. But also in terms, the area I think where we could probably do better on both sides is making sure we're engaging better and the right people are talking to the right people in the business. It was only as part of sort of today and getting involved with today, I sort of learned I could get a full report from you for each one of my sites, per mix, per like we just saw, understanding the carbon emissions all the way back to verified sources. So that's something I've been doing with other members of my supply chain. But now I know I've got it from yourself. So that's really going to help me out and really help us focus that communication to our clients as well.
What I find really interesting is when we find companies with a similar sort of mindset to us, it's not just the direct things that we do in trade, it's what you're doing about decarbonisation of tools, vehicles, etc., etc. Because we haven't got the answers to those things, and it's really interesting just to copy, to share and to copy, indeed, because I think it's that network is so important.
Yeah, definitely.
Yeah. So what do you think the construction industry can do together to try to achieve this decarbonisation more quickly? So you've got your 2030 commitments, we've got our 2030 commitments, but is there anything we could be doing like today, tomorrow, to really drive and push this forward?
So I think one of the biggest challenges that I see is probably Carey's position in the supply chain as well. So by the time we join the conversation quite often, our ability to make change is a bit too late, and that's scuppered by the British standards that we've got to comply with and the specifications of our designers. But that is getting a lot better, and I know there's a load of work going on to make sure these cement replacements can be increased and we can improve that. So I think that speeding up would really help, and then also having these conversations collaboratively of all parties in the supply chain much earlier on in the planning process. So right at the forefront of planning, can we just minimise our volumes rather than even thinking about cement replacements and alternatives, and then having those decisions earlier, I think, is the way forward.
Just before I ask Simon the same question about what we can be doing sooner or quicker, what you said about getting early engagement and collaboration, what do you think we should be doing differently then in terms of forums and networking? And is there something we're missing? Is there something obvious we're missing?
I think it is. I think we're getting a lot better. So I think we're members, Kerry's are members of Concrete Zero Group. So that's a really good network that I've been involved with quite recently since my time at Kerry's. And that is a lot of what's been presented today has come out of, and I know those discussions we've been having in that forum. So I think the networks are really good, but it's making sure when we're speaking to, when our sales divisions and our procurement divisions are sort of speaking to each other, that they're trying to find out who the person in that business is who they should be speaking to, essentially. And then I think that person can then help influence and educate others to make those right decisions, or to even at least consider alternatives.
Yeah, I know we feel exactly the same. I think we're further down that supply chain than you are. Mm-hmm. So by the time someone comes to us, they're often telling us they want this particular material, whereas if we could have got involved with the client, never mind the contractor, and have that conversation, well, we could do this differently, then I'm absolutely convinced that together we could make a massive difference. Thinking about it from a manufacturer's point of view, what can we do as a building materials manufacturer do to help you? What sort of things could we do?
Well, I think, so we've talked a lot about engagement, but I think that is really key, so having those early conversations. But one thing which could be quite controversial, but is the cost, I think, of innovative products. Because as they come into the market, and I'm speaking to my sort of estimators and saying we should look into include this, everyone, the go-to is, it's going to be really expensive because it's low emission. And quite often I understand that needs to be the case because of the innovation that goes into it and the research and development. But it's moving quickly from that premium price and closing the gap to make it viable. So people don't have that view that low carbon is expensive. So we close the gap on price, I think, and try and get there as quick as we can. So the traditional options are just as viable as the new.
No, that's a good point, and I think we've talked earlier on about the idea of using less as well, which is obviously a cost benefit for yourselves and for the client. I think one of the big things that makes a difference is the cost of carbon as well, and a consistent, comparable level of carbon pricing means that saving carbon is offset by saving carbon taxes. So yeah, absolutely, I'm convinced we can get to that.
So how, you obviously talked about carbon and the data, and actually the importance of getting that data. How much of a challenge do you have with the data that you're currently getting? And do you see, like Nina pointed out, that maybe we're not comparing apples for apples and there might be an apple and a pear in there? How difficult is that for you as a customer? And how can we change our behaviours to sort of help you to understand it and make it a lot more streamlined and easier? Yeah, so it is really difficult. It's the biggest challenge we've got, really. So obviously scope 1 and 2 we've got a handle on because it's all of our majority is our direct. We've got the procurement. We know exactly where we are. The scope 3 we really struggle getting the data. So and obviously that finding out today that I can get very transparent reports is exactly what we would need from our wider supply chain. But I think the challenge is to try and have those conversations as early as possible. At Carey's, we're trying to digitalise the process, so understanding what those carbon emissions are earlier on, so we can digitalise it we can capture it in our point of procurement, so we don't have to then rely on the supply chain is really important. But I think that is the challenge, really, I think. But when you say digitalise, is it sort of actually the interfaces between the two systems, or is it actually just having the data so you can analyse it from your client side?
Yeah, so I think having the data is obviously one thing, so we can accurately report. So I think we started off as a business, when we baselined, we were looking at data and carbon from a spend analysis, so it wasn't very transparent. So we were making some really good procurement decisions around concrete and other key commodities like our reinforcement and our plasterboard. We were making some really good procurement decisions, but because we were viewing our carbon calculation as a spend-based analysis, we weren't getting any sort of benefit from that as a business, or able to communicate very well. So I think this year, financial year 23, we started to look at focus on our biggest hotspot, which was our ready-mix concrete. And we were working through with our supply chain, and where we couldn't get the information from our supply chain, going mix by mix and by volume to understand our carbon footprint in that area. And that's where it's really helping us understand informing procurement decisions, basically be able, if we get a specification from a supplier, from a client, we can go back to them and say, well, actually, we've got these options we can use, and obviously that a lot of collaboration there with yourselves to get there and inform our clients. Well, actually, we can meet your specification with this lower carbon mix.
And how often is this for, I mean, you've got a very clear objective, you've got your 2030 targets, and I can see, well, we know what Kerry is trying to achieve. How much of this is for you internal reporting, and how much of this is the client actually asking you? And are you seeing competitive advantage from this in your space?
Yeah, definitely. So I think, obviously, a large part of the data gathering exercise is to inform sort of my annual report, and I want to be able to see that sort of annual carbon footprint. I want to see it more in real time, so I'd like to see it monthly at least, which is a big part of the challenge. But in terms of competitive advantage, yeah, for sure. I think we're seeing lots of tenders come in now for sort of BREEAM outstanding buildings and lots of projects that are in the sort of energy transition sector. So there are questions that come to us. So we're given a designer's mix, and we are asked sort of early contractor involvement to sort of try and improve that. And within Carey's, we do a lot within the design team to first of all see if we can minimise the volumes of products, and then also look at concrete mixes and then improve them, and then also our temporary works, whether we can sort of reduce our temporary works, which will obviously have a carbon benefit as well.
Who do you think's got the biggest influence on your carbon performance then in your business? Probably Simon to start with, and then Dan from a project's point of view.
Well, I think inevitably, if you think through the three things I said at the beginning about, the first thing is reduce the amount of cement that we use, and I have to say that's often the client or the specifier, in the engineer, the architect, the specifier, and partially the contractor. But I can sell it, but I can only sell what people are willing to buy. And I think that's the real interesting thing. Often those engineers or ultimate client have got a view on it. And I think for me that's why this sort of conversation, this sharing of information is so important. So, yeah, I think it's the specifier and the clients.
And what from your side?
So I'll go internally first. Internally, I think, so yeah, it needs to be from the leadership, which it definitely is in Carey. So there is the company want to do the right thing and move in the right direction. So that has to be there. I need a lot of influence for our scope 1 and 2 with our plant and fleet departments, and then with our procurement and our pre-construction for that scope 3 element. But I totally agree. For me, the biggest influence, like I said earlier, really is probably having the client designers specifying these low carbon products, and that will really help us, because we will essentially procure and install what we're told to, and if we can improve on an already good specification in terms of carbon, then that's even better.
Brilliant.
Brilliant. Well, I think we're going to wrap up this conversation, but we're now going to go to the last few minutes. If you've got any last few questions to ask, we're going to now be joined by Nina and Elliot and Gareth, who's going to join us on this panel, and we're going to start to go through some of the questions that have been coming out and coming through throughout today. And the intention is we're going to try and answer as many as possible within the time frame we've got. And if we unfortunately can't get to everything, what we'll do is we'll put together a Q&A piece online after the event, along with all the slides and the recording. So people, if they don't answer the questions quite now, we'll obviously make sure we answer them on the recording or online. So there's a few questions here. Hopefully some aren't too tricky. So Simon, sorry, the first one for you, not to pick on you, but the first question is, so how far away are we from having a commercially viable alternative to Portland cement?
I think you've got to answer that question thinking about concrete, because actually that's the product that we use. So yeah, I don't think we're close to having a viable option for concrete, but we know we can reduce the amount of Portland cement that goes into concrete, as we've talked about quite a lot today. Unfortunately, where we are is that every alternative material that we've got requires something to activate that. And I'm sure Nina can explain that a lot better than I can. But it needs an activator. And at the moment, the best activator is undoubtedly cement. And we haven't got anything available at scale that can do that. But we've got lots and lots of projects going around the world. One thing that Heidelberg Materials, I think, is really good at is collaborating. So what we're trying in America or in Africa or wherever, we actually have access to that. And Nina, through her network in particular, sees that. So yeah, I think we're a long way from having something available at scale that will eliminate OPC, but we can reduce it. If that's I guess that if that's a pointed question, if somebody out there is asking that because they've got something that we don't know about or they would like to talk to us, we'd love to talk to you. So please get in touch, and we're constantly looking for opportunities to do exactly what you describe.
Brilliant. Nina, anything from your technical side in terms of that?
It's almost, I can really only confirm what Simon has said. I believe we will need OPC still for many, many years ahead of us, because it is really one of the best activators. And I think the key is using what we know, the OPC, with probably future replacements, where at the moment clearly we know GGBS very well, we know fly ash well, they work well, but we will work increasingly with new supplementary cementitious materials, and that's where we are actively involved in getting to know them. And not only, as Simon said, in the UK, our colleagues in Germany monitor regularly what people discover and whether there can be alternatives. I think the question is what can work at scale. When you think about how many million tons of SCMs we use as well, we need to find something where there's a regular and also a consistent supply of it, so that it does perform consistently in concrete.
I suppose it's that scaling up which is the challenge as well. Okay, Gareth, one for you. What will happen to the CO2 in the CCS in the long term? Will it remain captured as gas, carbonised surrounding rock, or gradually leak and be emitted?
No, it's a great question. If you take around the UK, there's billions of tonnes of storage capacity. That's why these projects are going ahead. But we're actually filling up what depleted gas wells, oil wells, which is basically where the CO2 has been derived from initially. So essentially we're putting CO2 back in the gas wells, and that's absolutely secure. There's no possibility of leaks, and there's an infinite time in the storage as well.
Simon, just coming onto that question to you. You and I were having a conversation about the availability and the opportunities that we've got in the UK around that storage and that whole storage economy. From your perspective, we've talking to group in the European countries. What's our view in terms of that storage capacity and opportunities it might give us as a UK PLC?
I think this is really interesting, because if you think about it, back in the 1970s when we started using natural gas, and since then we've developed that and we've become a major producer of natural gas. I know those volumes are reducing in the UK, but I've heard estimates of between 44 and 70 billion tonnes of storage capability, which is a significant proportion of Europe's storage capability. And then I suppose the thing that comes with that is the UK has in some ways deindustrialised over the last few decades. And I think this is a real opportunity. In HyNet, which Gareth talked about earlier on, there's a small number of us in this first phase, but the second phase of HyNet is what we're all starting to talk about. And over half of the people that are interested in getting involved with the second phase of HyNet are people who aren't operating in the UK or aren't operating in the Northwest. It's people who see that opportunity of zero carbon hydrogen at scale and the opportunity to collect and store the CO2 to actually decarbonise and invest in the UK. So I see it as a huge opportunity for the UK and something that I think we all ought to be very excited about.
Yeah, I know when we've talked about it and the number of times we've talked about the opportunities at HyNet and the green economy and the green jobs that are going to come through this decarbonisation journey. So that's fantastic. So Simon, one for you. To incentivise the circular economy model, would Heidelberg consider implementing a take-back scheme for demolished concrete and asphalt?
Yeah, that's a great one. Yes, yeah, absolutely. I mean, we talk about I talked about the acquisition of the Mick George Group. That's a massive recycling business that's in the east of England, and we brought them to learn from them, learn what they do. But absolutely, we're totally up to that idea. The idea of taking back materials. And the hubs that we're setting up. So we've just opened a new hub down on the M4 corridor. And that's a site where we can sell asphalt, we can sell concrete, we can sell aggregates. But now we can take back recycled asphalt planings, we can take back demolition arisings, utility arisings, reprocess them and sell them out alongside recycled material. So I guess we're starting to do that. But yeah, absolutely, let's do more of it.
Dan, just a quick one for you then. So in terms of your construction sites, do you think there's a lot will there be a massive shift change or mindset change around the value of that concrete waste in moving forward as we go into more of a circular economy?
Yes, definitely. I think obviously there is already value in sort of our concrete waste in terms of a secondary aggregate that we use quite often on site. But we're already starting on projects at the moment to send sort of our waste concrete from our concrete pumps and things back to be processed, to be put back into. So we're all back into concrete. So we're already investigating that. And I think, yeah, there's definitely an appetite for it.
Brilliant. So there's an appetite for at the construction site, which is fantastic. So Nina, one for you around data and carbon. So what's the timeline for updating and adding to the Heidelberg EPDs to cover all mixed types in Heidelberg?
Okay, there are probably two parts to it. In terms of cement and GGBS EPDs, they actually have been all prepared with the latest manufacturing data and have just been submitted for verification. That in itself is now with an external verification body. It's out of our hand, but I would hope that within the next 1 to 2 months we will have new updated EPDs for cement and GGBS, and our intention is actually as of now to probably update them every year to show the improvements we make. And in terms of concrete, what I presented before, in terms of the estimate at the quoting stage, that is something which is available now, and it uses the data which I showed in my presentation. It will use the new data from our cement and GGBS EPDs, which is actually the most important data because that is where most of the carbon comes from. But then, as I explained, even the carbon associated with our concrete operations and with our aggregates will in future also be certified data.
Okay, so watch this space. And we'll no doubt be sending out some more comms when they're available. So, Simon, there's a question, well, there's a bit of a statement here, but then there's a question at the end. Great plans on show here. You are taking responsibility, but if you could ask one thing from your customers to help you on your journey, what would it be?
Oh, that's a very difficult one. Great question. I think it's just almost like the last question you asked in the session before, Marian. It's about get us involved and get the contractors involved early on these projects. There's lots of examples that I can think of where we end up on a project and we're supplying a material and we're sat there thinking, this doesn't make sense. We could supply a material that's got half the carbon content and reduce that, but it's specified, it's baked into the client's requirements, and it's very, very, very hard to change that when the order's placed the day before. So yeah, get us involved and get us involved earlier. I guess going with that is a little bit about be a little bit more, a bit less cautious. sometimes if we want to change this is something that we've got to change quickly, because the world is changing very quickly. And I think we've got to actually crack a few eggs to do that. And so, yeah, if we've got data that products that maybe haven't been around for tens of years, but we've got good data that it's going to work, let's try it. Let's go out there. And I don't mean short-term one-off trials in low-risk areas. Let's go out there and be a little bit braver sometimes.
Yeah, and I think it's really important that we're sharing our case studies and our best practice when we do things as innovation, so we can share that and get that knowledge out into the industry. So, Elliot, one for you around taking maybe a bit of a risk and a bit of a punt. So, hydrogen. We talk about hydrogen and its opportunities for decarbonisation. Is it a real option? Why haven't we moved this cement onto hydrogen?
That's a really good question. I think it's definitely a real option. We've proven it within cement as a direct fuel replacement. We've also done some work around looking at using it more as a fuel enhancer, which could probably be a more cost beneficial solution. It's yet to be proven in asphalt, but again, hopefully we'll do that maybe towards the end of the next year, but definitely the start of the year after. We're starting to see some noise in the hydrogen market around its use within HGVs, but also heavy mobile equipment, so the big yellow equipment we use. So yeah, I think it's definitely there. There's a lot of noise around it at the moment. I think there's a lot of excitement within the industry, but at the moment it comes down to cost. It's very expensive. We used, during the trial, I think we used most of the UK's supply of hydrogen in around 3 hours, which is, pretty significant. But again, there's a lot of government support out there. There's hydrogen allocation rounds, number 2's coming up soon, and there's going to be 3 and 4 after that. So yeah, definitely it can be done, and hopefully the costs will come down, potentially in line with natural gas, or it could be a little bit more expensive. But again, that market's not yet established either. So yes, it can be done. We're really excited about it. It's just a question of cost and when that's going to come to a price where we can use it commercially.
But I think, just to add to what you just said there, is it's really important that we understand how to use it. I think what we've learned from the work we did in cement and the work we're doing now in asphalt is just the practicality. And it's not just engineering, it's not just chemistry, it's also logistics, it's also economics. And I think understanding that, and then it just opens up our mind and it connects us with people who are trying to do the same thing. So if we understand that price curve for hydrogen, because it will get cheaper over time, we know where we can be competitive. And then as Elliot said, we're looking at other things there. We're looking at where we can use much smaller quantities of hydrogen to actually enable us to have a bigger effect, to leverage that small quantity of hydrogen to enable us to use other fuels. And I think that's really exciting as well. So it's being involved, it's learning from it, and being ready for when the conditions are right.
Okay. Dan, one for you. Do you think, is there anything we're missing that we need to provide you in terms of data so you can make those quick decisions we talked about? You said you'd love to have your carbon footprint on a daily basis. How do we get to that point?
I think, so it's quite often we sort of approach yourselves and ask for a low carbon option, but it would be good if we went to you with an option and it wasn't as low carbon as it could be, it comes back the other way. And then I think that will obviously catch those that fall through the net, which perhaps a buyer's not thinking that about the carbon element. And it might trigger that conversation and that consideration.
Is that having that two-way conversation? Yeah, absolutely. So Nina, one for you. Which SCM innovations do you think are promising?
The loads out there at the moment, but I think the ones which are actually already to some extent accepted in standards, because it will make the rollout, the use of them easier, are the ones we are most looking at. So at the moment I would say certainly calcined clays, because it is actually established technology. It is available already even in some European countries. Within Heidelberg Cement in Africa we are using it already. So that is high on my priority list. Natural pozzolans, we must not forget the Romans used them already. Again, they're even written into our UK concrete standard. We probably don't have them in the UK, but with efficient transport options from Greece, from Iceland, they could become an option in the UK as well, so it's something else. And then we come into the areas where The other big one, I think, which is coming, are certainly beneficiated fly ashes as well. That, again, within Heidelberg Material is already reality in the US. We talked about before how we learn within our own group in the US and in Canada. We are already using beneficiated fly ashes, and we can learn from their experiences. And we know that in the UK, there's significant lagoons there as well. So that is the third sort of, these are, for me, the three big options. And then you are into the more exotic ones, like the electric arc furnace slugs in future if we switch. These require more long-term development, but could become another option as well, and contribute to circularity again is one of their advantages as well.
That's there's some really good options, and obviously and one of the 2 or 3 of the questions that have come through is around what are the concerns over the long-term supply of GGBS as a low carbon cementitious replacement product. So, Simon, do you want to take us on that?
Definitely. I mean, domestically in the UK, things are going to change. We know what's happening at Scunthorpe. We know what's happening at Tartar in South Wales. So yeah, things are changing. There's no doubt. And I honestly believe in another 10 years' time, domestic GGBS will not be available in the UK. As Nina says, we don't exactly understand what the opportunities are with all sorts of different processes for making different slags that could have a cementitious effect. I think the thing to remember, though, is that GGBS will be available internationally for the foreseeable future. It's interesting, isn't it? Nina's just talked about a number of SCMs there, and the only one that we can think of that's got long-term domestic availability is calcined clay, which is why we're looking at it so significantly. If we think about all of the other ones that we talked about, they would be secured internationally and transported to the UK. So yeah, as we move away from prime iron production in the UK, then yeah, it will become less available. But I'm confident we can source it in the UK by importing internationally for quite some time. I guess the only thing to remember is as we reduce the amount of GGBS that we do use, at the moment that will actually increase the amount of cement we use and increase the carbon intensity in the concrete. So that's something we need to bear in mind and balance in all of our calculations.
Okay, so nothing to panic about at the moment. One question that's come through, Simon, is, and I think probably, again, you might be the best to answer, is we talked about collaboration. We've talked a lot about collaboration, talking to this throughout the supply chain and engagement, and innovation being so critical to get to a true net zero. How can the risk of innovation be shared between the suppliers, contractors, and clients? Risk as in, being the first to do something, but also risk to have a unique sort of opportunity in that area.
Well, I think that's a really good question again, isn't it? I'd be interested in Dan's view on this one as well. But I guess it's through sharing the data, being realistic about the testing that's being done. I think Nina's alluded to it. We have got an inordinate amount of data globally about how these products perform, and I think being open to seeing what's happening in another country in Europe or another country around the world, and actually taking that information rather than having to do it all ourselves. So yeah, we don't want to have massive failures, Marian. It's really important. I mean, as I said earlier on, these products are around for a long, long time. We don't want to make mistakes. But I think if we work together and we do that testing and share it on a global basis, then I think the risks are relatively low. I don't know what your view on that is, Dan.
Yeah, I totally agree. I think it's the earlier we can get involved, the better. If there's a specific goal and project where they're considering using, we have done that at Carey's. We work with suppliers and we've done full mock trials and all the testing to go with it. And then once we've done that, sharing the data so it can be used if it's viable and if it's worked. The more we do that, and again, I mentioned Concrete Zero earlier, but then promoting it potentially through there to the network of people that are interested in decarbonising concrete sounds like a good solution to me.
Excellent, good. Now, I'm just getting a note flashing up that we've got to, unfortunately, wrap up these questions. There's still a few that we haven't answered, but again, as I said, thanks for all the questions and joining in for this afternoon. I'm going to hand over to Simon now just to wrap up the day, but I just want to thank everyone on the panel for their time, energy and effort, and obviously everyone online for your engagement today. So thanks a lot from me. And Simon, over to you.
Yeah, well, thank you, Marian. I hope you've enjoyed it. I hope you've learned something, and I hope our examples is, I think, very exciting, but there's plenty of other examples out there, and I think the message is clear for me. We want to work with everybody, anybody who's got any ideas, anybody who's working in this sort of space, whether they are other material suppliers or whether they are contractors or clients, then we want to work together. I mean, I was really interested to hear about recycled concrete place. It works, but it's not easy. It's something that we need to think about how we segregate it, and we need to think about downcycling, where we're crushing up concrete, we're not segregating it, and we're using it as a cheap fill, because Nina told us about how we can actually upcycle that. In asphalt, again, lots of things we're doing to reduce those scope 1 and scope 3 emissions. Hydrogen, use of wrap, alternative binders. Lots to do, but you know, the message was clear to me. We can only do that through collaboration, and we heard that from many people in that presentation. Gareth told us that carbon capture is a reality. We know how to do it, and we're doing it at scale around the world. That's very exciting, but it's not going to happen at scale in the UK for another decade, and so we can't wait for that. We need to do things sooner. But yes, it's going to happen, and it's going to take time. Nina explained about Evo Zero, so that's the product. Zero carbon cement. We'll be selling that from next year. It'll be available either as a physical product or as a virtual product. So please, if you are interested in that, please get in touch. It's a real opportunity for us to get to understand how to use this sort of product and how the market will react to that and the clients. So please do that. I think the message is clear as well about data. We've got lots of it. It's not always clear, and there are inconsistencies between countries and between companies. And we've got to sort that out. We've got to do our part for that. I hope you understand how we measure our cements and our concrete from what Nina told you today. But we've got to do more to make sure that we all do it the same way, because we might not have it right, and everybody else might not have it right. Smart rock, other opportunities to optimise the usage, to be able to design better concretes with lower SCMs, with higher SCMs and lower cement. It seems obvious, but again, we've got to be brave. We've got to take those opportunities. And then Dan told us what it looks like from a client of ours, a contractor that's absolutely determined to make a difference and has got the same objectives as us. And with people like that, we can work together to share knowledge and to share those things. It's about collaboration. So yeah, thank you very much to everybody that's joined us today. Thank you for the questions. If there are any questions that we haven't managed to answer, we will answer those for you. This is recorded, so we'll share that and put that on our website as well. And thank you to everybody who's made this happen, both within Heidelberg Materials and our friends who are working in the same space that have shared their thoughts as well. I hope you enjoy it. It's changing. It's changing incredibly fast. I can't believe what's changed in the last 2.5 years since we first talked to you about this. But we're making progress. We're making progress as Heidelberg Materials, but we can only do it if we all do it together. So thank you very much, and watch out for the next Let's Talk Sustainability event later on this year. Goodbye.